wind speed and profile. We have wind shear, and wind shear basically shows on how the topography, how obstacles, buildings, trees slow the wind down. Alright, so if we have trees and buildings, they will obviously slow the wind down as it hits them. And this in turn creates a wind shear diagram. Alright, now from that wind shear diagram, you've got wind speed along the bottom and you've got height up the side. And this wind shear diagram follows a profile, something like that, which is disrupted at the bottom, obviously by your trees and your houses, and then things like mountains and things like that there. And this is why the wind is going much slower at the bottom than it does the higher you get up. So this is why we're putting turbines much higher. This is why there's more wind available much higher. And also another point here is we need to look at, wind turbine designers need to consider this. If they're putting a turbine alongside this, and in this case a two-bladed machine, we need to think about how fast the wind blows on the top blade and how fast the wind blows on the bottom blade. The difference here could be as much as 2 meters per second. This meaning that the top blade maybe takes a wind speed of 8 meters per second, and the bottom blade, when it's at the very bottom, takes a wind speed of 6 meters per second. This means that there's a greater force pressing on the top blade than on the bottom blade, and this means that there's an awful lot more pressure pushing on the top than the bottom. And as these blades turn, the top blade's always going to get more pressure, and this makes a force on the front hub and the front bearings, which actually causes wear or damage to the turbine. So this is very important for wind turbine designers.